All right, we'll go ahead and get started here.
Sure.
So welcome everyone to our Anton webinar. So for some of you were with us for a previous webinar covering the capabilities of the Anton special purpose MD supercomputers. And this session is going to be about how you go about writing a successful proposal for time on one of these systems. So the previous session was recorded and will be made available. So if you missed that one, we'll be sharing the links to both of these webinars with participants once they're available. So you'll have a chance to catch up on that. Also, anything that you don't quite follow from this presentation, we'll have a chance for questions at the end. You can also ask questions during the talk as well, and just put them in the chat, and then someone will be monitoring the chat and will stop me as I present, and I can answer questions along the way as well. But we should have time also at the end for further questions. And then, of course, all of this will be recorded as well and will be made available. And then please also feel free to write to us. So there's an email address right here on this front slide where you can reach us for questions as you are preparing your proposals,
Right.
and we can help you with those. Okay. So we'll go ahead then and dive in. And so I want to welcome you all to this webinar. My name is Phil Blood. I'm the Scientific Director at the Pittsburgh Supercomputing Center. I lead the Anton project at PSC, and I'm joined by several of my colleagues here from PSC today, as well as colleagues from D.E. Shaw Research, which develops the Anton systems and makes one of these systems available at no cost to the general scientific community through Pittsburgh Supercomputing Center. And so we're going to explain in this webinar who can apply for time on the Anton system at PSC and how you go about writing a successful proposal. And there's a lot of text on these slides, and so I'm going to try not to read all of that to you today, but I'll hit the highlights. And again, if there's anything that is not quite clear, feel free to ask a question in the chat, and at the end, we can go into more detail on the things that may not have been totally clear, of which you just like further information about. So just to get on the same page, again, I would refer you to the previous webinar if you didn't see it, when the recording's available, it goes into much more detail about what Anton is. But it's not like anything that you've ever run on before. If you haven't run on an Anton system before, it's really specially designed from the hardware. All the hardware is specially designed for one purpose, and that's for biological MD simulations. And so because of that, it goes much faster. It's much faster than anything else, about 100 times faster than any other system out there, no matter how many GPUs or other regular processors you throw at your MD simulation. That simulation is going to be at least about 100 times slower than what you would be able to do on Anton. So I already mentioned designed and built by D.E. Shaw Research, made available at no cost to PSC, but we also are supported by the National Institutes of Health, in particular, the Institute of General Medical Sciences at NIH, provides operational funding for Anton so that we can make it available to the broader scientific community. And that's all without cost. You just have to write a proposal and convince the reviewers that you're well positioned to make good use of Anton. And we'll talk more about that review process during this webinar as well. There's a number of links throughout these slides, which, as I mentioned, we'll also make the slides available along with the video, so you can follow along those links. Maybe Rosita, we could drop a few of these links in the chat here too while we're going through this.
Sure.
Thank you. So yeah, so think about running 100 times faster than what you're doing on any other system you're using right now. And so about 3 or 4 days of that, and you've done as much simulation in a few days as you would have done in a year on any other system. So that can be pretty incredible, especially if you think about testing different hypotheses and be able to, in sort of real time, figure out if something is, promising or not. And so it really is a game changer in terms of how you might go about designing and planning and following different lines of inquiry, testing your hypotheses and getting to something that is interesting very, very quickly. You can split these simulations, however, whatever length of time you want, and run, very short simulations to start with to get an idea of what you really want to do. But then what we've focused on for most of the time, you're really going to want to focus on long time scale simulations, because that's what Anton is there for, is to really go much further than you would with any other system that's out there. So that's what you're going to have to show when you write a proposal. And as I mentioned, it's for biomolecular systems, so nucleic acid, lipid, protein, or anything that's made up of these things. And also people use it to test out different new force fields, as long as they're sort of made available in a form that Anton expects and can work with, and that's sort of basically as long as it's compatible with something like Amber or Charm, those kinds of the popular biology force fields. And also we're generating these long trajectories, and it's really important that in your proposal, I'll just put this out front. I think maybe I didn't write this somewhere in this talk, actually. They really want to have, because you're going to be generating a ton of data with Anton, you can imagine how long these trajectories are going to be. Definitely, you need to have a good plan for how you're going to analyze the data and how you're going to pull out the results from these very large trajectories that you've got. So if you don't have that, I guarantee some reviewer is going to bring it up. So make sure you've got a good plan for what you do after you generate these long trajectories and how you're going to manage that. So again, it's for these long time scale simulations of biological systems. The deadline for proposals is October 21st. We might say a couple of times in here that there is a system that you have to submit to. So kind of like if you're submitting an NIH grant, you want to be sort of in the NIH system before, before the deadline. You don't want to try to set up your account and things on the day of the proposal submission. So go ahead and read the RFP and go to the site that it tells you to and set up your account. Do that now, right? If you don't do it at least a couple of days before the deadline, we may not be able to help you when you submit. So go follow the process, set up your account so that when you're ready to submit, it just goes through. So a couple disclaimers up front to help you out. Who can apply? So you have to be faculty or a staff member at a U.S. academic or not-for-profit research institution to be the PI of the proposal. So current rules are that a graduate student or postdoc can't be the PI of an Anton proposal, but obviously could be a co-PI. So you need to have the advisor in the lab be the PI, and also again, so it's for open research. So no for-profit things allowed in terms of this particular opportunity. Also, you can only be PI on one proposal. So that's an important, we want to spread this out to give everyone a chance as possible. It's a limited number we can accept. So we don't want, one group to be sort of benefiting multiple times. So now sometimes we do have a situation where a PI is putting in their own primary application, but they also have a collaborator that they want to provide some support for, who is submitting their own proposal. That's okay, as long as it's really clear that it's really the PIs are the ones, really those two distinct PIs are really the ones driving the project. If the review panel gets the sense that one PI has become a co-PI on another one, but is really the driving force behind that other one as well, and they're really kind of trying to get two proposals in there for two of their projects, then neither of them may get funded in that case. So double dipping is something we're a little sensitive to, again, because we can only accept a limited number of people. So make sure that it's really the other lab's work if you're supporting another lab as a co-PI. And then, but we also, we again, as part of broadening, the participation in Anton and everyone getting a chance to use this resource, we welcome people who have never run on an Anton system before. We don't want just the people who've run on it before, getting all the time. So we kind of target that. This usually happens naturally. About 25% of the total allocated time goes to the people who have never run on Anton before. And so, don't hesitate to apply. We invite people who are doing this for the first time. And we'll try to help you as best we can to prepare and get everything ready, through things like this webinar, and then, any follow-up questions that you have in answering those. Okay. So the idea here is to do things that you couldn't do anywhere else. And so that's really one of the main things that you want to emphasize in your proposal is what are you doing here that you just couldn't do on a conventional supercomputer or a conventional GPU cluster? And those are the types of problems that you really want to target to get the maximum scientific merit score on one of these proposals. But you also got to make sure that you meet, there's a number of technical requirements that you have to meet to be able to run on Anton. So you want to make sure you really read this request for proposals document. And so maybe, so if there's a link to the PSC website, that's how you get to the request for proposals or RFP document. And so I'll call that the RFP from now on. So go there, read that RFP really closely. Wherever it says do this, make sure you do that. Grantsmanship is going to be very important in this, and making sure you cover all your bases. So part of that are those technical requirements, and then there's a bunch of required sections with some very specific instructions. So just sort of go line by line there, make sure that your proposal has the things that it asks for. And again, you can always email us if you have any doubts about this. That said, these aren't designed to be really long proposals, so you'll have to be succinct to usually convey. We didn't want it to be a big burden for people to submit one of these either, but we do ask for some very specific information. So just make sure that that's in there, and then build around that sort of further explanation if you're struggling with the 6-page limit in length. You can provide some supporting documentation of papers and whatnot. Reviewers are not required to go look at those, but you're welcome to provide them. And as I said, you'll pay very close attention to grantsmanship. We'll have a few more things to say about that as we go. So this is the basic outline of the RFP. So I'm not going to go into this in a lot of detail because it's just written there in the slides and it's in the RFP and you can read it. But do pay very close attention to all the information it's asking for here. And so, I talked about the scientific objectives. Again, why is Anton necessary? It's a limited resource. We want it to be used for the things that really only could be done on an Anton system. And generally that means you're going to be exploring sort of longer timescales than you could explore in a single trajectory than you could on a special or a regular supercomputer. Because if you divide that up too small, if you're running a bunch of small simulations, you could do that just by having a bigger supercomputer and go spread those out, across a big supercomputer. That's not what we're trying to do here. Okay, so yeah, and then it can only be done on Anton is one piece, but then what is the actual scientific impact of what you propose to do? And that's that's the other part of it, is that it should be sort of uniquely suited for Anton, but also, of course, should be of high scientific importance. We're looking for breakthrough science. Okay, so that I think I just covered right there. So we'll keep going here. So you do want to talk about your team and your qualifications. So and then you want to make sure that the technical piece of it is solid in terms of dealing with the what are the constraints for running on on an Anton system. So I guess that's these first 5 points there. Those basically are the technical requirements, and so you can look there, double check that you're running in the right regime there of that's supported by Anton. You're doing standard biological, systems. You can bring custom ligands and molecules. That's fine. So I want to highlight that. As long as you're using, one of the MD packages that's supported in terms of transferring over to Anton, and using standard amber charm, parameter type force field parameters. Okay, so that's basically what that says. There are size limitations. Oh, we didn't update this. So this says 250,000. It's actually 100,000. We made that smaller. So yeah. So it's going to be between 100,000 and 8.5 million atoms. We have a restriction here because Anton is even though it's only 64 nodes. If you were in the talk with Ken before, you'll realize that 64 nodes of Anton is like over 30,000 processing units. And so if you're down to 100, even at 100,000 atoms, you've got like 3 atoms per processing unit. So if you try to spread that out too thin, it's just going to be a waste of time. It won't be efficient on the Anton system. And then if you go to the upper end here you really probably don't want to go to 8.5 million unless you really, really have to, and it's a really strong argument for why you should. The sweet spot is kind of between 0.5 million atoms and 6 million atoms in terms of performance. So I'll just lay that out here. I'm not sure if we say that in here. You probably won't get dinged too much in the review panel. I don't think you'll get dinged if you're not necessarily in that sweet spot, as long as you have strong scientific messaging there and rationale for why you need a system that's on the smaller side of that sweet spot, or a system that's up at the very tip top of the range. And then this last one is just a protection against, like, sort of rule of thumb, like if your simulations finish in like the ones you're proposing, now you might do a few like tests and things like that. That's fine. But as far as like your production simulations, if what you're envisioning is going to run so quickly it finishes in less than an hour on Anton, that's probably too small. You'll be wasting a significant portion of your time just having it load your system in there and get it prepared, before you start running the system at that point. So so that means there'd be a lot of overhead for such a short simulation, that it would be not a great use of the time. So yeah, and then the more you can talk about how so this is in terms of your team qualifications and your preparation for running this system. So the reviewers really want to see that you know how to build the kind of system that you're planning to run on Anton. I mean, it's supposed to be novel, and so there could be some, obviously you're doing something new, but they want to see like a track record of being able to build and run these kinds of systems successfully. If it's doing something that's really kind of out there that really you've never attempted before, really fundamentally different in some way from anything you've ever done, that may not be the best fit. They want to see that you have like the background and skills as a team to be able to do what you're proposing to do. That's basically all I'm saying there. And then you have a plan for how you're going to build this. If sometimes just building the system and getting it equilibrated can be a lot of work. And so if you can come and say, this is not a requirement, but if you can say that we've already done this much, right? And sort of show them how well set up so that they have confidence that this is going to work out. And so if the system's already built and equilibrated, in some other program, by the time you submit your proposal, then that can give the reviewers a lot of confidence, for example, that they've already tried to put this system together and it works. Now, I would say a lot of people aren't at that point when they submit the proposals, and that's okay. You just, whatever you can do to give reviewers confidence that you'll be able to really do what you're saying you're going to do, that will help you. So that gets to what you've already done, and also sort of experience and expertise. And this last bullet is just reemphasizing that the work should be primarily being done in the PI's lab. If it's primarily being done in the co-PI's lab, especially if you've got another proposal in there as a PI, that's going to raise suspicions of we're just trying to get more proposals in to one lab. And then we talked more about this again in the previous webinar, but There are some enhanced sampling techniques support on Anton. It supports position restraint and also application of a uniform constant electric field. So this is all in the RFP as well. And you are going to, whether or not you get your system pre-equilibrated and sort of built and all that before you submit the proposal, you will have to do that before you can run on Anton. You don't go to Anton to build your system. You're going to build that in Desmond or Amber or Charm or GROMACS or NAMD. One of these standard packages, you'll set to build it, and you'll want to equilibrate it as well in one of these standard packages and then bring it to Anton. Anton is not a great place to equilibrate your system, so you'll want to you'll definitely have to build it in one of these other simulation packages and then do some running of that in equilibration before you get to Anton. So just plan for that. If you are familiar with the Desmond package, which was developed by D.E. Shaw Research, getting your simulation into that format before will be the easiest transition to Anton if that works for your workflow, because Anton uses the same kind of file formats and such as Desmond does. So that's a sort of immediately compatible with Anton. But most people we know aren't using Desmond, so it's fine to prepare it in one of these other popular packages. You'll just have to do some conversion of formats when you come to run on Anton. We wanted to highlight here that PSC is a supercomputing center, so we have our own supercomputers, general purpose ones that you can use to run NAMD or Amber or Charm or GROMACS. And so you can use our big systems to help equilibrate these big and prepare these big systems that you're going to run on Anton. So we encourage folks to check that out. Maybe we can share these links in the chat too. Go ahead and check that out. Get an allocation through the NSF Access program to run on Bridges 2. And you can bring your system there and start to prepare it, get it all prepared on Bridges 2, and then run on Anton. Okay. All right, and then this one I think is important. You just want to really make it easy for the reviewers to see how you got from here's my research plan, here's the systems I'm going to run, and therefore this is how much time I'm asking for on Anton. So I would say do it like third grade math. So just write out all your work in your proposal from how you got from what your plan was, the systems you're going to run, how many times you're going to run each system, and from the benchmarks, how long it's going to take to run each system, how many there are, and then just multiply that all out and just show your work, and then therefore that equals this much time that we're going to need to run all these systems. So just make it really easy for them to see that, so they don't have to guess and wonder. That's going to hurt your chances at getting that if that's not clear. So to help you with that, we have all these benchmarks in the RFP, so for various sizes of systems. And so you can take these numbers and kind of just interpolate between them to get an estimate of how much time it would take for your exact system size to run on Anton. And these are not going to be exact, but they'll be close enough for the RFP. This is just take note that these were using 2.5 femtosecond time steps, and they have the RFP has the details on how these benchmarks were done. But this is probably close to an upper bound on the performance you should expect. Some systems don't love a 2.5 femtosecond time step, and there may be other things that you need to adjust there. So just kind of be aware of that. I mean, the reviewers aren't really going to look too closely at that, but as far as if you just use the benchmarks here pretty naively for your estimate for the proposal, that should be good enough. Just be aware for your own planning that this is probably an upper bound for most systems in terms of performance. Okay, so yeah, then I just said calculate things out. So if you're running this system and you're going to do 10 of them, and then you need to get to a certain number of to test your hypothesis, and you say, okay, I think I'm going to need to run it for this many microseconds of chemical time, and if you can give some justification for why you think it has to be that long, then that's ideal. Sort of like some sort of scientific justification for why you need to run it for 200 microseconds to observe some biological phenomenon. That's ideal if you have some really good justification for the length, and then you just multiply it out, like I said. So it's 42 microseconds a day. So if you have to do 200 microseconds, then it's going to take several days on Anton. And so you can calculate that out, get the exact number of days, and just show those calculations in your proposal so the reviewers can really connect the dots between your proposed plan and how much time you're asking for. So I've emphasized that a few times. That's really important. If you have had an allocation on Anton before, make sure that you submit a progress report. We will not accept your application if you don't have a progress report and you had a previous allocation on Anton as a PI. Now, I think right now that includes if you ran on Anton 2. Okay, so if you happen to run on Anton 1 but never ran on Anton 2, then we're not going to require I don't think we look back that far. But if you had an allocation on Anton 2, send in a progress report if you were the PI. If the PI is the same, from that previous allocation. So then, it's 2 pages. Again, you just want to show that you had success with what you did previously on Anton, or you want to really, especially if you didn't have success, then this is really important because you want to explain, what happened. Did the postdoc leave? Especially if you didn't use your time. That's like the worst thing possible, right? That you didn't even use your time. You got an award and didn't use it. So again, that's be like, okay, it was COVID, our lab shut down, just explain the situation if like you left a lot of time on the table on a previous allocation or something like that. Otherwise, just tell about all the great things you did and how it supports, that you can do, what you're proposing to do. Okay, so this is, just reasons to talk to us. So if you are doing, custom parameters or molecules, and you have any doubts about whether it might be supported on Anton, feel free to email us. If you're really going heavy on the restraints, like if it's involving dozens of different restraints, maybe on thousands of atoms, talk to us. There are because this is such a fast, sleek sports car. I mean, think about like a sports car that doesn't have all the bells and whistles of like an SUV, right? So it's very optimized, and so things like this can make a difference, and you can run out of memory, or other things, you can hit other limitations. So so if you're dealing with thousands of restraints, just talk to us. Make sure that you're not doing anything that's going to break it or not be able to run. And also, can be a gotcha. Sometimes you have a weird simulation cell. And now they all have to be orthorhombic. That's one of the requirements, but maybe it's like a big long rectangle. So it's one dimension is much longer than the others. Let us know if that's the case, and tell us what you're planning, because we want to make sure that sometimes that can cause a problem, or at the very least, it could substantially slow down your simulation time or your performance. So on that system. So just let us know. And again, you'll contact us at that email address. Okay, so we've got some common issues. So the number one issue is just not really writing a great grant. So what the thing you don't want to hear a reviewer say is fishing expedition when they're talking about your grants. You really want to have a clear hypothesis and a clear plan for how you're going to address that hypothesis. And then again, like just the other thing we find is that they didn't really drive home like, why is this so important? So again, we're looking for breakthrough science here. How is this going to be great? And then so that's sort of the scientific side of it. And then the rest of the stuff. So those are the 2 big scientific things: is it a clear hypothesis, a clear plan, and then is it clearly, have you justified why it's important? And then the other things are a little bit more mundane, right? So it's not clearly justified, like why is this guy the co-PI, but most of the work, it looks like it's doing just following up on other work from that co-PI's lab, and the PI looks like a figurehead. That we don't want to see that. So be careful about that if you're on multiple proposals as a co-PI or and PI. And then, yeah, again, like I said, you don't show your work on how much time you're requesting. So they can't really connect, like, why are we asking for this much time? That's a big one. Why do you need Anton in the first place? You're proposing like a lot of little simulations. So you want to make sure that you justify that and in terms of the research problem, as I've mentioned now many times. And yeah, then I mentioned this unused prior Anton allocation. That's you got to explain that, or else you're probably not getting more time. Okay, so that is some of the pitfalls, and then here's just a lot of the sort of the details of how we the process of submission. This is the so this is the link to the Anton website that has all the links for submitting your proposals. So just that's basically your one-stop shop for everything. The RFP is there as well. October 21st, so basically a month left. Make sure you go today though and create your account so that it's all ready to go. You don't forget, if you're trying to create an account at the last second, then we may not be able to accept your proposal. We are going to try to help you though with the technical feasibility. So do go through the RFP with a fine-tooth comb and make sure you're doing all the things that we ask you to do, that the things that we say you can't do, you don't propose to do. You're meeting all the technical requirements, but we will do a double check on those technical requirements for you. And so we kind of try to help you out a bit with that in case you happen to miss something. There are a few things to keep track of there, but do the best that you can there to get all that aligned with what we say in the RFP, and then that will give you the best chance of having your proposal all completely coherent and consistent and clearly able to run on the Anton system. Just want to make sure folks know that the review, and I should mention this at the beginning, the review is not run by PSC. And so since the beginning, it's been run by the National Research Council at the National Academy of Sciences. So they do lots of reviews, and we wanted this to be a really independent review process, rigorous and transparent. So the National Academy does the review, and so they will actually, they're building the review. Once the proposals are submitted, once we know who's submitting a proposal, then they can build that review panel, and they'll actually publish the committee on their website prior to the review. So there will be a period of time when, if you're interested, you can go to the National Academy's web page and see who's on the review panel, and they're open to comment. So if you think there's someone there that shouldn't be there, send National Academies a note explaining why. And we take that really seriously. We want this to be absolutely fair and give everyone an equal shot at getting time on Anton. And then once so there'll be a review period. We expect, what do we expect? I think it says here. So notice of proposal acceptance by the end of January. So there's a bit of a wait. You'll submit in October. It'll be end of January before that will be official. Once that happens, we'll notify you and we'll give you instructions for accessing the system and starting to access the documentation and other things like that. And we'll also notify you of a workshop. So we'll do a workshop that is for just one day, but we get a lot done in that one day. For everyone who's awarded an allocation, we'll come and help you get your system set up. So the more you can do to prepare your system prior to that April, we're targeting April 1st as the start date, 2026 for the allocations. And so anything you can do to prepare what you're planning ahead of time. If you can bring your system to that workshop on April 1st, then we'll be able to hopefully help you get that up and running on Anton that same day. And that will save you a lot of time and hassle. Okay, and then just a couple of notes. You'll have access to your files for, so your allocation will be for 1 year. You'll have 1 year to run all your simulations, but then you'll have access to the files for a year after that, so you can do all your analysis and take care of all those things. We want to encourage everyone to acknowledge the Anton project. This is how we'll continue to get funding to be able to keep providing this resource to the community. We also, collect, PhD theses and anything you generate from Anton, please send it to us, and we will hopefully continue to justify our funding and stick around, make it available to the community. So yeah, so we do keep all the data private until publication. Generally, though, we're looking for about a year after the end of your allocation that we want to see like a manuscript. we try to follow the NIH policies of open data access and rapid access to data for the community. So we will be sharing your data at some point, but we want to be good partners and not do it before you're ready if possible. But basically, we give people about a year, and then we really sort of want to get that out there. But you can get a little more time if for various reasons. But we're trying to be sort of open and sharing with the community, aligned with the NIH data sharing principles. And then we are going to just we're keeping and collecting all these trajectories, so you can also benefit from this, because we'll have all these Anton trajectories. We're still working on this, but hopefully this comes in the next year, where all these resources, these trajectories, really from the beginning of the Anton project, like 14 years ago, will be available to the research community, and so it can be used in machine learning applications and other applications, and reanalysis and so forth. So this is basically it. We've showed these links a few times, and I think this is the survey form, and Rosita will make sure that you get that in the chat as well. We want to know if this webinar was helpful to you. And so I'm going to go ahead and stop here and answer any questions that you have.
Phil, we have a couple of questions that I just wanted to read here.
Great.
So one of the question is about how competitive is the application? Could you provide some statistics on the percentage of accepted application? So I couldn't answer that one.
Yeah, it all comes down to sort of how much time is available. And so I'll say that generally we get requests for about 2 to 3 more times the computational time as we can provide. So yeah, so we've got to cut the amount of time requested. Now sometimes that happens by cutting, but we do try to make it as we give people as much a chance to do something as possible. So what we tend to do is generally what the review, I mean, this is really all done with the review panel. Again, it's an independent panel, but we give them direction and what we're going for in terms of the project. And so generally what will happen is that rather than rejecting you outright, if possible, the review panel will give you some time on Anton, but it may be just significantly reduced from what you requested. But the very best proposals will get all the time they requested. Okay, so you're really competing on time. Now there are there are a number of applications every year, of course, that don't get any time, but we try to be as fair as possible and spread it out as much as we can without but while still funding fully those that were deemed by the review panel as the most meritorious. So I say somewhere between 2 and 3x more proposal time than we can accommodate every year. But some years are weird, like it's I can't quite pick out the pattern yet, but some years we get way more than other years, and then we have to cut more. So it's a little bit, but some years we get less than we expect too, and then you know it's more. So it varies a bit on that, but I would say that on most years, sort of the average is 2.5 to 3 times, you know, more time than we have available.
Awesome. So another question is from Elika. She asked, "What should we put in our like a report?" We recently started this, like from April. We started running simulation, and obviously we didn't have time to publish anything. So just what I said is that just if you have any interesting result, you can put it in your report, but wanted to double check with you.
Yeah. So this is to be clear, this is a group that has an allocation now on Anton 3.
Yes, yes.
Yeah. Okay. Right. Yeah, that is always a challenge, right? So yeah, you've got a report here in October. And so I would say that, you know, the review is going to happen in, you know, December or probably. So, you know, there's a little more time to make progress. I think, you know, one of the things is yeah, they will look at the utilization and such. Although what I do tell the panel is, because of this very fact, like what you just described, you know, to not, you know, be too harsh about, you know, something that is coming you know, this current year, because for that very reason, you haven't had a lot of time you're still in the middle of your simulation time. But I would say, you know, do whatever you can to run your simulations, especially between now and when you submit, but also, you know, before, you know, if you can continue to make progress, like before, you know, December, then, you know, any progress you can show there is good. I don't know if we've had people send updates before in terms of sort of the last. I mean, I'm not sure that we've done that. I don't think it comes into, yeah, I don't know that it comes into too much play there, but if you have really concerns about that, reach out to us and we can, you know, kind of talk through it. Yeah, I think you want to show some progress, like using your Anton allocation. Like if you haven't used any of your allocation yet by December, that's going to stick out. I mean, that doesn't mean like, but if you're afraid that like you're going to have to, don't rush your time just for that. if it's going to be like, you know what I'm saying? If you're going to have to cut corners and not really do what you want to do sort of systematically to show usage, that's probably not the best thing either. So just talk to us and let us know what's going on, and we can help you.
Thank you very much. We have one more question. Joshua asked, are we given a storage space to hold our trajectory data? And if yes, so yes. But how large would it be, like in terms of gigabyte or terabyte?
Yeah, good question. Yeah. So we have a number of methods for limiting the size of the trajectories, because, you know, these are, you're not going to be probably writing your trajectories as frequently as you would with regular, you know, MD applications and on regular supercomputers. So we'll provide some techniques, and we could put this out even in the RFP if it'll help people for a plan for, you know, how they're going to manage the data. As I mentioned at the beginning, that is important to have, you know, some plan for analyzing and processing the data. So we might want to think about for making that available to some extent, maybe, you know, share that out to as an update. We do have some ways to compress that. I can't remember, you know, how much the compression. There's a few strategies we use to reduce that. There's different things but some of it's based on what you really need to capture. So I think I would just put some thought when you're writing your proposal and you're planning your strategy for how you're going to analyze the results. You just think about what information you really have to need and what's the time scale that you need it on. Because, you know, the less frequently that you can save, then the less data you'll have to deal with. And some things happen on it, you can save too frequently for sure, for the time scales of the phenomena that you're looking at. We're looking at sort of long range, long time scale things here is kind of the general purpose of Anton. So on what time scale do you really need to have that granularity? One thing to keep in mind with Anton as well that I didn't mention, I'm not sure if we highlight in this RFP too, so maybe we should make a note of this also, is that Anton, unlike other supercomputers, is bitwise reproducible. So that means that if you start with the exact same starting conditions of a trajectory on Anton and you run it twice, you will get the exact same trajectory, exact same positions. Okay, everything exact same velocities. There's no variance there. So what you can do in Anton that you can't do in other systems is run a simulation at a certain and save the trajectory at a certain interval. But then if there's like a piece of that where you really need a more fine-grained view, you need to save your coordinates and other things at a smaller interval, then you could actually go back and just rerun that smaller part of the trajectory, from that, that starting input point, that same, where the interesting behavior begins, and you will exactly reproduce that piece of the trajectory, but just with, more data. And so there are some techniques like that you can use to try to mitigate the fact that we're running these super long, timescale things. But that's all kind of a prelude to answering your question, which is that we don't have a sort of a set, I think, quota sort of decided yet for Anton 3, as we're trying to still sort of figure out what these are looking like in practice. Generally we'll have several terabytes of space is what I expect. For at least, and then on a case by, or maybe we set a quota, I can't remember now, but we will work with you. If you are having troubles with with a limitation on space, then we'll work with you and talk with you about, okay, how can we optimize this? Okay, you really need more because of this. We'll give you more allocation. So yes, we provide storage. It's definitely not unlimited. There's lots of techniques to reduce the size of your trajectory. And we will work with you if you need more space than we initially allocate. These are good questions.
Okay, so now let me read the next one. Well, someone asked, where is the public trajectories, how to access them? So I think it's a...
Yeah, so this is something that we are going to do, but we haven't done yet. So it's still in the works. We've done it a little bit in the past, but it was so small scale that we kind of took that away, and we're working towards a much more comprehensive release of Anton data. So look for that in the future. We'll definitely make an announcement. I'm hoping basically in the next year, that we will hopefully something before the next year, like an initial thing, but then have it in sort of its full form in the next year or so. So sometime during this next year, we should be making an announcement about the initial release, and then we'll be building on that over time to hopefully make this a really valuable resource.
Awesome. Okay, thank you. And I think this is the last question. Sergey asked, where one can see the supported MD integrators. The slides with the benchmarks said that the time step is 2.5 femtosecond, and the non-bonded interaction were not computed at each time step. So how flexible one can be in the simulation protocol choice, where I can find this specification. Also, how do I know that? For example, computing the non-bonded interactions every 3 time steps won't adversely affect my simulation in terms of quality? So I think this question should be
Yeah.
or 10, I think, or
I think probably, yeah, I mean, I guess my quick take would be you probably don't need to get to that level of detail in your proposal. So just propose that you're going to do reasonable things. And I don't think you need to specify the integrate. So you're not going to be using like, the integrator that you use on every other thing. So there's, the Anton has implemented, similar algorithms in using methods, developed by D. Shao Research. So it's going to be a little bit different than what you're used to, but it's essentially equivalent to other things that you're using. So I wouldn't worry about that for the proposal, and then just propose reasonable stuff, and then when you actually win an award of time on Anton, then we can help you with what the specific parameters and such should be. And for most people, the default parameters are fine with a few exceptions.
okay, it seems that